Good morning everyone. Welcome back to this GYAN course titled Characterization of Agricultural Particulate Materials for Effective Handling and Processing. I welcome you all back to this course and I hope that you learn a lot from Professor Kinsley. And now, sir, I hand over the stage to you for the lecture further. So, this will be an introductory session.
Okay.
Thank you, sir.
Thank you. Yeah. Yeah, that's what I was asking. How many of you know Purdue? You all know Purdue University? Yeah, okay. I just wanted, that's why I was trying to connect to internet so that I can get a video pull out. I forgot to copy on my this one. But Snehida would, I know Snehida would have seen that video, but just to give an introduction, till we figure out. Okay, you all know my name, right? Yes. So I graduated with bachelor's and master's from you all know TNAU, Coimbatore, okay. So Coimbatore, and then I'll connect it. I just pulled it out. Yeah, so that's fine. Thank you. Oh, it's connected. Oh, it's not connected. I think it's still connecting. Let's see.
Let's check the other.
Okay.
LAN we require from here.
LAN, yeah, I need the LAN.
You need the, we can put hotspot sometime.
What's that?
You need the video only, no? You can give the hotspot to it. You need the LAN throughout or just throughout?
No, just for what? No, I can put hotspot. Yeah, that. Thanks for reminding me.
That's fine.
Okay, so after my master's, I worked for ICAR. You all know ICAR, right? How many of you heard about CFET? CFET. I worked for close to 6 years, where Dr. Godke came from there too. Right? So then I went for my PhD at Purdue. Then after my PhD, I was a faculty at Kansas State. Any of you know Kansas State University? So I was there for 4 years and then went back to Purdue in 2015. Okay. So it's been close to 9 years at Purdue now. Okay. So you all heard about my area of work, right? So my expertise is in particle technology. Okay. Mostly anything to do with particles. Okay. Oh, okay, great, thanks. I just wanted to show you a Purdue video. That's why I was trying to connect to internet. Thanks, Dr. Godke. So when I was a PhD student at Purdue, I had lots of friends from IIT Kharagpur who did undergrad from here. They're all in, working in US, Bangalore, etc., many places.
So please connect.
Hold on, I will, hold on, give me 1 minute. That's okay, I'll just show the video first, so class is not, I'll just show the, this. So this video shows like Purdue campus a little bit, okay? Not all, a little bit, so it's a little old video, okay?
When we talk about our best moments, they include humanity's first steps on the moon, alongside stories about the steps we're taking right now. At one of our country's greatest institutions, Purdue University. Beauty, highlighted by brick, its fountains and traditions. The campus that stretches across 2,500 acres, nestled in the heart of America. You can feel it in the hearts of the people here. Hardworking, welcoming, and guided by integrity. A family of students and professors who are in this together, all taking the next step, one foot in front of the other. The kinds of innovations that will help solve the world's greatest problems. Persistently pursuing, relentlessly thinking. The next game changers, difference makers, ceiling breakers, innovators, boiler makers. And we will never stop. Keep going, because there's so much to uncover. And we keep going because discovery is in our DNA. We keep going because it's just as much about the journey as it is about the win. This isn't just a home. This is a launch pad. A community that will propel you on your course, out into your limitless future, filled with promise and purpose and all the tools and resources for your personal mission, encumbered by nothing, empowered by everything. We are removing barriers and raising expectations. Stand up, Boilermakers, each and every one. With more than 630,000 alumni, have your back for life. 2 words say it all. Boiler Up. Our greatest adventures are yet to come, and they include you and everything we will experience together when you take your next giant leap.
Just a old video about Purdue. Okay, so that's okay. You would have heard about Neil Armstrong, right? So Neil Armstrong is one of the famous alumni from Purdue. Okay, what's that? Someone said something. No, you can hear me. Okay, right? Voice. Okay. So there are many famous Purdue alumni in India too. Anyone know any Purdue alumni in India? No? Go ahead.
Dr.
Pidam Chandra?
Pritam Sarkar. He's a NIT rocket.
Oh, okay. Yeah. Okay, he did. I know him well, yeah. Pritam, yeah. So he did PhD there, yeah. So, any of you ride TVS bikes? Okay, so TVS chairman is one, famous Purdue alumni from India. Many of you know Dr. C.N.R. Rao. Heard about Dr. C.N.R. Rao? So he was a Purdue alumni. Any of you from? Oh no, he's acting in Hindi movies too. Any of you know Dulquer Salmaan?
Yeah.
Okay, Dulquer Salmaan is a Purdue alumni. Okay, so there are many people around. Again, Sriram Honda chairman, he's a Purdue alumni. There are many, big personalities in India who are, from Purdue. Okay. So again, I'll talk more about my research. So, I work mostly on, particles, powders, and compacts. Hopefully it works. Okay. No worries. I can do it. So this is a little old slide. So most of my work, as I said, particles has applied to ag industry, but I do work on pharmaceutical stuff too. Pharmaceutical, solids. Oh, thanks. Yeah. Pharmaceutical solids too. Any of Gatorade, energy drink. If you watch soccer, football games, you might see large Gatorade cans on the side for the players to drink. So I worked on it's manufactured by PepsiCo. Now I worked on modeling mixing of those powders. They make Gatorade from about 15 different types of powders. So mixing uniformity is a big challenge. So we developed a model for them on mixing of those Gatorade. Grain damage is one of my major area of work, modeling grain damage. So I worked with CNH and now Bayer too. When we harvest, we lose about 5 to 6% of grains, during threshing, mechanical damage. So we continue to develop some DEM, discrete element, models that they use to modify their threshing, both threshing, cylinder design and also threshing operation design. Okay, and In particle design, one of my recent work, I do work on slow release fertilizers. So how can we make urea release slowly without adding any chemicals? How can we structurally modify urea granules so that the release of nutrients are in a much slower fashion, right? And couple of my students are working on it. And then sensing dispersed dust and dust explosion prevention, mostly funded by USDA. We're trying to use imaging or video methods to get the amount of suspended dust in confined spaces. That's again one of my major area of work. And I do lots of again characterization, small works for pharma industries, etc. Okay. One of the recent project that we just started is 3D printing of pharmaceutical tablets. The company has a 3D printer, but we are not working on 3D printing per se, but we're working on like how to make them level. The powders, before printing, how can we make it very level so that the tablets they print are like in uniform size and shape. Okay, so those are some of my again projects. So I'm as you introduced, I actively involved with the ASABE. Actually, I'm the community editor for processing now. I look for if you are interested in reviewing papers, let me know. I can suggest my associate editors to send you papers to review. And I also encourage you to submit papers to ASABE. ASABE journals, the impact factors are not very high, but still it's highly recognized by the professionals in the field. Right? So again, we'll be talking for 4 days, but still I want to learn from you your name, your major degree research topic, etc. Okay. I might forget now, but over the course of 4 days, I will come back. Hopefully, I will remember all your names when I leave. Okay. So why don't we start from here? Except I know a couple of people, Ankur and
Hello.
Sneida from TNAU. So go ahead, Ankur. Yeah.
Hello. Good morning, everyone. Hello.
Yeah, I think it works. Yeah.
Myself, Ankur Singh. I am a student, MTech student in food processing engineering. I am working on project development of tomato sorter under the guidance of Bhupendra Godki sir.
Okay.
Thank you.
Okay. Thanks, Ankur.
My name is Parthiv Patel. I am doing MTech in food processing engineering. My research topic is development of assisting unit for rapid drying of the fragrance drying of mango berry under the guidance of Bhupendra Godki.
Okay. Okay. If it's difficult, you can sit and introduce too. That's fine. Yeah.
So, good morning, respected professor and all everyone present here. My name is Sanjana Vatam. Currently I'm pursuing my masters under Professor P.S. Rao, and my project topic is design of a millet grader, design and DEM simulation of a millet grader.
Okay. Okay. Great. So you started using DEM?
Yes, sir.
Okay.
I'm using Altair EDM.
Altair. Okay.
Yes, sir. Only like I motivated from your research.
Oh, I'm sorry.
Research
No,
papers.
it's okay. Okay.
Good morning everyone. My name is Olpathan and I am a first year PhD research scholar in food processing.
Okay.
And my research topic is on design of plant protein extraction equipment
Okay.
using electricity.
Which plant you're using? Which plant protein?
Till now, sir, I haven't decided, but mostly
Okay.
I'll be using high mixture.
Okay. Okay.
Hello.
Good morning, sir. My name is Hina Sudhakar Tambi. I am PhD research scholar first year.
Okay.
I am under Professor Rao sir.
Okay.
My broader research area is development of process frying of food, especially vacuum frying, sir. Vacuum fry.
Take
Vacuum fry.
vacuum fry.
Yes.
Oh, okay. Okay. Good. Thanks. Yeah. And again, I said I might forget your name, but hopefully by the end of this week I will remember all your names. Okay.
Hello, sir. I I'm Saima Nigar, and I have currently joined PhD over here under Professor Praveen Kumar Sapati, and my broad area of research is plant protein based food product development.
Okay, good.
Thank you.
Thanks.
Good morning, sir. Good morning, everyone. I'm Polumide, a first year student of MTech Food Process Engineering of this department.
Okay. Great. So you haven't started any research here?
I will start from second.
Okay. Okay. Okay.
Good morning, sir. Good morning, everyone. I am Preetha Mandal, and I am a second year student of MTech Food Process Engineering at IIT Kharagpur. And my research topic is ultrasonic processing of milk and preparation of Indian curd or dahi from ultrasonicated milk under the guidance of Professor Anit Mandal.
Okay. Great. Yeah.
Hello sir, good morning. Myself Snehita, and I have joined your first year PhD, and I am working under Jayata Mitra ma'am. My area of research is detection of oil adulteration system.
Okay. Great.
Good morning, sir. My name is Mayank Dikshit, and I am enrolled in MTech Food Process Engineering. And my topic is I am working on developing a hybrid frying technique, and my supervisor Professor Brijesh Kumar Pandas.
Okay.
Good morning. Good morning, sir. I am Tista Mohes. I am a final year student of BSc Agriculture from Brainware University.
Which university?
BSc Agriculture.
Which university, sir?
I am a final year student.
Yeah, which university? University.
Brainware University.
Okay. Okay.
Good morning, sir. My name is Devasis Bakshi, and I am pursuing masters in IoT in Computer Science and Department.
Okay. Okay. Please stand up and talk. Oh, okay. Sorry, yeah, for recording purposes, okay, not for me. Okay, go ahead.
Hello, sir. I am Somish. I am taken up a project on baking of bread by using hybrid baking technologies.
Okay.
That is on ohmic and infrared heating, under the guidance of PP Tripathi, ma'am.
Okay. Good.
Good morning, sir. My name is Harshal Bhoite. I am second year postgraduate student at IIT Kharagpur, and I am currently working on electrostatic separation of protein, equipment for electrostatic separation of protein under Praveen Kumar Sapati, sir.
Okay. So from cereal grains? From cereal grains? From grains?
No, sir. It is an equipment for electrostatically separating protein, dry protein particles.
Yeah, from which products?
I have currently selected soy protein as
Okay.
a source.
Okay.
Good morning, sir. My name is Aryan Dubey. I am currently pursuing masters in food process engineering from IIT Kharagpur.
Okay. Good.
Good morning, sir. I am Rishi Sachan. I am pursuing my MTech in IIT Kharagpur.
Okay.
Good morning, sir. My name is Samarendra. I'm a scientist working in ICRC-ISS and working on micro-installation of biotic compound.
Okay. Which institute is that?
Central Institute of Subtropical Horticulture.
Oh, okay. Okay. Good.
Good morning, sir. My name is Prashant Kumar. I am second year PhD student, and I am working on sustainable protein through dry fractionation.
Okay.
And currently I am working with Professor Rao.
Okay. So if you are second year PhD, then you all should, if you are especially second year, you should try apply for Sir Purdue, postdoctoral doctoral fellowships.
Hello, sir. Good morning. I am Mukta, and PhD scholar here, second year, under the guidance of PS Rao, sir.
Okay.
Good morning, sir. Thank you for the opportunity to introduce myself to you, sir.
Sure,
Myself, Prakash. So, I'm pursuing a doctorate, and I'm majorly working on seaweed processing and utilization, the major component from the seaweeds.
Okay.
Thank you, sir.
Okay, thanks.
Good morning, sir. I am Yogavendra Kumar. I did my masters in food process engineering from NIT Rourkela.
Okay.
Currently, I am working here as a project staff on GRA position under PS Rao, sir.
Okay.
Yeah, thank
Great.
you.
Yeah. So, are you a student of Preetham, Dr. Preetham?
Yes, sir.
Okay.
Good morning, sir. I am Shreyash Yashwant Shirsat.
I did my masters from Institute of Chemical Technology, Mumbai.
Okay.
I worked on non-thermal technology, cold plasma.
Okay.
So I explored the effect of cold plasma on maltodextrin.
Okay.
And currently I am working as a junior research fellow under PS Rao sir.
Okay.
Thank you, sir.
You introduced right already, yeah.
Yeah,
That's
we already
good.
met.
Yeah,
So I'll introduce myself. I'm Dr. Ronit Mandal. My area of specialization is food process engineering. I'm assistant professor.
Okay. Great.
Good morning, sir. I am Kushal Thomre. I am pursuing MTech in Food Process Engineering from IIT Kharagpur. I am working on rapid detection of tea quality under Dr. Abir Chakravarti.
Okay.
Thank you, sir.
Good morning, sir. Myself Anup Kumar Sardar, and currently I am doing MTech in Food Process Engineering second year, and my area of research is 3D printing of foods and vegetable for personalized nutrition.
Okay.
And under the guidance of Punadasan Poonam Tripathi ma'am.
Okay.
Thank you, sir.
Great.
So good morning, sir, and fellow participant. My name is Mandar Moe. Currently, I am pursuing Masters in Food Process Engineering, second year MTech student. So I am working on the study of different pretreatments and quality kinetics of millet-based vacuum fried snack under the guidance of Professor P. Srinivasa Rao.
Okay, great. So,
Good morning, sir,
Yeah.
and everyone presented here. My name is Aniket Masne, and currently I am pursuing a Masters of Technology in Food Process Engineering.
Okay.
And my research topic is development of calorimetric indicator for milk spoilage using nanoparticles under the guidance of Professor Kanik Bunia, sir.
okay, great.
Thank you.
Good morning, sir. My name is Rajshekar Hasda. I am an undergraduate student of BSc Agriculture in Vishwabharati University.
Oh, okay. Do you, by any chance, do you know Dr. Gautam Mandal?
Yes, sir.
Okay, you know him, okay. He was my past colleague at ICR, okay. Yeah.
Good morning, sir. I am Chayan Mandal. I am also UG student in Vishwabharati University.
Okay, okay.
Morning, sir. I am Akash Sunil Koivarto, and I am undergraduate student of Agricultural Science at Vishwabharati University.
Oh, okay, great.
Thank you, sir.
Good morning, sir. Myself Hilal Dea. I am the second year MTech student from IIT Kharagpur. My research topic is to development the low glycemic index rice.
Okay.
Thank you. Under the guidance of Dr. Joyita Mitra.
Okay.
Good morning, sir. Myself Mukesh Kumar. I am PhD second year student. My research topic is design and performance evaluation of dual stage low temperature spice grinding machine.
Oh, okay.
Under the guidance of Dr. S. Thangalakshmi.
Okay.
Thank you.
So I don't know, maybe Dr. There was lots of work on cryogenic
Yes,
grinding long time ago. So you're using cryogenic process too?
Yes, sir. I am currently PhD from NIFT and Sonipat.
Oh, okay. Okay. No, then, yeah.
Good morning, sir. I am Sitesh Kumar. I have recently completed my PhD degree in Food Process Engineering at IIT Kharagpur, and my research topic was effect of cold plasma processing on quality and self-extension of kiwi fruit juice,
Okay.
working under the guidance of Professor P.P. Srivastava, sir.
Okay.
Thank you, sir.
Great.
Good morning, sir. My name is Anindya Krishna Basu. I am first year MTech student from Tezpur University.
Okay.
And I haven't started any project yet, but my research interest is on the nanotechnology in food applications
Okay.
and extraction of bioactive compounds.
Okay.
from this.
Great. Yeah.
Thank you, sir.
No problem. Yeah.
Good morning, sir. Myself Anand Kumar. I am MTech student. My project topic is microencapsulation of okra mucilage, characterization and process optimization
Okay.
under the guidance of Professor Bhupendra Mangurki.
Okay. Good.
Good morning, sir. Myself Nishant Ghormare.
I am currently pursuing Masters in Food Process Engineering at IIT Kharagpur. I am working on development of test method for degree of milling of rice under the guidance of Professor Brajesh Panda.
Okay.
Good morning, sir. My name is Yoshim Kaping. I am currently in my second year MTech. I am working on safety of quality of Asafoetida under the guidance of Brajesh Kumar Bantas.
Okay, sure. Thank you. No problem. Hey, thank you all. So thank you all for introducing yourself, and thank you all for being here. Okay. So how many of you are excited to learn about characterization? Okay. At least for the sake of, for now, raise your hands. Okay, right? So that I can see all your raised hands, right? So when it comes to characterization, when we talk about characterization, what comes to your mind? So what do you mean by characterization? Okay, classification. Or someone said some other response somewhere. Okay, physico-chemical properties. What else? Okay, particle behavior. Yes, particle size. So there are tons of things comes to our mind, right? So characterization means like trying to put them in a group or class, right? So that we can use that group for further information, right? So how do we use, when to use, any kind of powder or material will depend on what type of characteristics that has, right? Like physical properties, chemical properties, etc., right? So why do we use this characterized material, or what is the purpose of this? Designing equipment. So can you give an example? This is your quiz. Yeah, quiz is on Friday. Okay, till then no answers are wrong in the class. Okay, so you can give wrong answers in the class too. Okay, but not on the quiz. I believe the quiz is on Friday. Okay, so again, so we use characteristics for pneumatic conveying, design of pneumatic systems, right? So what property we use for pneumatic system design?
Surface properties, how operation it will cost to the
Surface properties maybe, but there is major what's that? Terminal velocity. What is the property that determines terminal velocity? Specific gravity. Yeah, specific gravity means, what is specific gravity? Density. Okay. Yeah, so it's a density, right? So density is one of the major property that we use to characterize pneumatic systems, right? So that's a major property. Then particle orientation, that will affect the drag, all other things will come into play. Okay, but the major property will be, we start with density, right? Any other examples where we use property to design or anything?
Angle of repose design for
yeah, we'll talk about that. We use for angle of angle of repose as Hopper angle, but that's the wrong approach. We'll talk about that. Okay, so any other example? What's that? Okay, coefficient of restitution. Okay, yeah, I know you are working on DEM. Okay, I'll come back to that in a minute. So someone else said, what is that? Someone responded. Yeah, particle. So where we use application. What's that?
Binding properties.
Yeah, but I'm coming into property. Okay, so, but what is the application? Where do you apply? Okay, new food. How?
In pharmaceuticals for developing tablets.
Okay, go ahead.
Particle size is used for design of the screening.
Screens, yeah, screen size. Okay, so size separation, right? So particle size, one of the major and basic characterization that we'll have to do, right? And again, we'll talk more about that. Coefficient of restitution, again, yeah, maybe, okay, but how do we measure coefficient of restitution? Okay. Yeah, if I say that's wrong.
And the other way of measuring it, like velocity after collision divided by velocity before.
Okay. So basically it comes, we'll talk about coefficient of restitution later part of the class. Basically, how much energy we lose during impact. Okay, but again, I have used velocity before and after, but that's a wrong approach. But there are not many good approaches to measure coefficient of restitution. It's still evolving. Okay, so the major challenge here is, if you take about characterization, if you take, if you take any agricultural materials, right? We get tons of different types of agricultural materials, right? It could be food, like for example, Skittles or M&Ms. We call as M&Ms. Tablets, compacts, soil. That's corn cobs. That's piled in large piles, corn, fertilizers, etc. They all come in different sizes and shapes, right? So how do we characterize them uniformly? Or all these sizes and shapes makes it very difficult or very, very challenging to characterize or measure their properties of. Okay, hopefully we'll go through some of those characterization in this class. This is almost a condensed version of what I teach at Purdue. It's in combined class for mechanical engineering and ag engineering students, but chemical engineering and aeronautical students to take this class. So it's a condensed version of what I teach at Purdue. Okay, so but I'll not be able to cover everything in 4 days, but I'll try to cover more. Okay, so goal, we'll go through some of the characterization approach. Hopefully most of them, in this 4 days, describing different properties that used to measure sizes, shapes of particles, powders, and compacts. Again, I'll go through some of these fundamentals behind measurement of these properties and how these properties influence downstream processing, equipment design, etc., etc. Okay, I'll go through some of those examples. Okay, again, how many of you have calculators? You all? Okay, if you don't have, try to bring a calculator. Okay, we'll have some in-class examples. Okay, that you will be solving. Okay. So what do we care about property? Again, most of the time, especially when it comes to food industry, it's for quality, right? So for quality purpose, we need to know their properties, right? It could be physical, mechanical, etc. Okay, and okay, I'll just give another example. You all eat wheat flour, right? Chapati, roti, right? We use wheat flour, right? Do you know the size of that particles? Wheat flour particles. Food engineer, you are eating wheat, right? Rotis. What's that? Less than 250 micrometers. That's an excellent guess. Okay, but still not very close. But it's very, very close. Okay. Anyone else? So the average should be close to 140 microns, at least for the US standards. Okay, 140 microns is the we call this Code of Federal Regulations in the US. Okay. So how do they check for this size? In general, they any of you been to a wheat flour industry, wheat milling industry? No one? No one? Okay. So, if you go to visit any wheat mill, there will be continuous, rollers or, milling machines. Okay. So when from all the rollers, they collect flour and then they check the particle sizes, particle size matches, then they say, okay, it can go into that flour category. Okay. That's the simple basic check they do, but the most common check that they do is for ash percentage of ash in wheat flour. Okay. Do you know how ash affects wheat flour? Ash, percent ash, or mostly how much fiber it goes in there. Any guess why ash is important? Minerals. Maybe, when you mill into wheat flour, we don't get lots of minerals, very limited. So, anything else? Any guess?
Outer layer mostly contains the outer layer.
Not really. No, it affects the processing characteristics, processing behavior. Any guess? 1 more minute, quickly. What's it? Any guess? Okay, it affects the baking properties, okay, how puffy it becomes, okay. So, different ashes, if the percentage is ash is high, if the percentage ash is high, their baking property will be very poor. right? Especially if you wanted to use it for cakes and things, cake flour, we want your ash to be very low. But for wheat and roti, it can be a little high. But in general, they keep it as about 0.5%. Okay. So again, property measurement, again for prediction of behavior, right? When it comes to bulk, most often we don't measure their behavior, but we try to predict their behavior, right? How material behaves when it flows from a large hopper, large bin, and when we mix bulk volume of powder, we try to predict by using those properties, right? Most common you would have seen empirical correlations, right? Statistical correlations, statistical relationships, relating powder property or particle property to their final performance, right? Most often it doesn't correlate very well. We try to do some first principles modeling, like using their understanding, using their fundamental property, understanding the physics, like what mostly we do in DEM modeling. Okay, try to understand the physics and then use that physics to apply and understand their bulk behavior. Okay, for those, property measurements are very important, and again, selection of sub-samples for testing, right? I just talked about wheat flour, wheat milling, right? You cannot test the property of wheat flour all the time, right? 24/7. So we just go and grab maybe a half kilogram sample or 100-gram sample, like maybe once in 2 hours. Okay, but that 100-gram sample should be representative of like tons and tons of materials you are producing daily, right? So 100-gram of sample should equate to the tons of material. So how do we subsample or take surrogate materials for characterization, etc. Okay, and again we'll go through some of these. Measuring properties is very important. Okay, we talked about angle of repose, right? So that's why we always say angle of repose is not a good property to measure, but it's an easy property to measure. Okay, just as an example, if you see this pink color powder, how many angles you can measure? So if you take that pile of that powder, you can at least have like 3 or 4 angles of repose. So which one will be its actual property? We do not know, right? So it might not be, you can measure an angle here, you can measure an angle here, you can measure an angle here. So if you use either one of those values, for design purposes, the other 2 angles may not match, and then your design might be poor or wrong, right? So again, so that's why we say measuring properties is very important. Again, very commonly used for angle of repose, very commonly used for indicating the powder flow, hopper design, etc. But in general, it doesn't match with the actual bulk behavior. Okay. And we'll talk about angle of repose later on. Again, I'll skip through this. Okay, so there are tons of characterization approaches we use, right? So one common characterization approach is simulating the process experimentally, okay, or experimental measurement. So we do use different characterization equipments, right? We try to simulate the process and then measure the property of interest. Okay, so again, a couple of examples. If you wanted to see the bin outlet or opening of bin, how much minimum opening is needed for the material to flow, we try to use. I'm not sure how many of you seen an equipment called Flodex. Flodex, no. It's a small, it's not an expensive equipment. Small bin-like instrument. It will have a hopper opening with different orifice, openings. So you use different openings and see at which opening the powder will flow. Okay. So again, we can use that to simulate the actual process and measure. And also another example, attrition of tablets is not only in pharma industry but in food industry too. When you make compacts, the attrition is a big process, right? We lose materials or we lose products, right? So we try to simulate the process of handling by putting the tablets in a rotating drum and mixing for a period of time, and then from the amount of samples lost during this process, then you calculate the amount of attrition, right? Just to simulate the handling process. Okay. or we can use some measure fundamental properties and then use some models. It could be mathematical models or statistical models, and then define their properties. Okay. So this will be a little easier, right? So you know the fundamental property or fundamental value of the material, and then use some correlations. It could be, most often we use a lot of times we use statistical correlations to again extrapolate those properties, right? Very commonly you would have seen bulk density of different materials, right? So how moisture influence bulk density, you will see a statistical equation or relationship, right? So again, but there are other again physics based models too. We will go through some of those, at least for powder flow. Okay. I might not cover for tablet attrition or weir models, but there are physics based models too, right, that we can apply. But both experimental approach and physics based or theoretical based, both have their own advantages and disadvantages. But modeling, again, it comes from the physics based fundamental measurement, right? So that gives much more reasonable estimation of the property than an experimentally measured property most often. Okay. But again, the challenge is we do not know when the system changes. We still don't have the understanding of how the properties will change. Okay. Just one quick example. You might have seen large handling of powders, right, or grains, etc., right? So if you are conveying in a auger conveyor, their properties will be little different than when you use an use a, how many of you seen drag conveyors, drag systems? No, it's called paddle conveyors too. So their properties will be okay. I will not go into those. Again, the properties, the importance of properties when we change handling system will also be different. Okay. But again, we should be able to predict the bulk behavior, but again, we do not have much understanding from when we move from one scale to other scale. Okay. We talked about 100 gram of powder, right? So 100 gram of powder will have completely different property than if you are talking about a ton of powders. Okay, 1 ton of powder. So we still do not have much understanding on when moving from one scale to another scale. Okay, small scale to a larger scale. Okay, so again, very important to make measurement at different scales, and which is challenging too. Okay. So in this course of 4 days, hopefully I will go through sampling, some size measurements, and up to powder constitutive loss. Okay. So that's the syllabus for this 4 days. Okay. I will be learning in this class. So any questions? Again, if you have any questions anytime, feel free to stop me. Okay, just raise your hand. Okay, I will be happy to discuss or talk. Okay. Any questions? How many of you need tea? I'm just asking how many of you are still awake? You all are awake? Okay, it's good. So let's go to the next, or do you need a break? No? Okay.